Hey guys, welcome back to the channel. We're going to be solving the question 95 from the first chapter of Hibbeler textbook, Mechanics of Materials, and we know if the allowable bearing stress for the material under the supports at A and B is 1.5 megapascal. We need to determine the size of a square bearing plate A prime and B prime required to support the load, and we're going to go with the dimension of the plates to the nearest millimeter, and the reaction at the supports are vertical, and we know that the P is 100 kilonewton. So first of all, we're going to start with the free body diagram of this beam. So we have the force P at one end, we have two normal forces at A and B. We can call this one NA and the other one NB, and we have this distributed force that is symmetrical. We can replace it with one single force that's going to apply exactly in the middle of this. So this is where it applies, which will be 1.5 divided by 2. We know this whole distance is 1.5 meter. We have 3 meter in here and 1.5 meter here too. So this will be 1.5 divided by 2, or 0.75, and the force would be 40 times 1.5. So in order to find the unknowns that we have, we are in equilibrium. We can use the equilibrium equations that we have. Sum of all forces equals 0, and same for the moment. We're going to start with the moment about either point A or B to get rid of one of the unknowns that we have in here. So let's do the moment about point A, that way we can get rid of NA. So if we do that, we have the moment of the distributed force. The moment is going to be in this direction, so counterclockwise. It's a positive moment. So 40 divided by 1.5, that's the force, and the distance would be what we have in here, which is 0.75. If we look at it, we'll see that the moment of NB is also counterclockwise, so that one's also positive. NB times the distance would be 3 meters, and we have the moment of P. If we look at it, we'll see that P is going to make a clockwise moment, so it will be negative P times the distance would be 3.3 plus 1.5, or 4.5. And this will be equal to 0. Again, we are in equilibrium, so 3NB would be basically 100 times 4.5 minus 40 times 1.5 times 0.75. So basically we have 450 minus 40 times 1.5 times 0.75. That's going to be 405. So NB would be basically 405 divided by 3, which is going to be 135 kilonewton. So that's the force in NB. If we do sum of all forces in y direction is equal to 0, we can find NB2. So we have NA plus NB minus P, which is 100, minus 40.5. This is going to give a 60 kilonewton, minus 60 is equal to 0. So basically our NA would be 135, actually minus 135 plus 160, which is going to be 25 kilonewton. So now that we have the force or the normal force in each of these supports A and B, for finding the bearing stress, we basically have the force in each of them. So we either have NA divided by the area of A, and we have the same thing for B2. We'll have B over B. We know the area is a square from the question. We know that the size is, we have a square plates for both A and B, so we can just call them for A, we're going to call it A as the dimension of that square. And obviously for area of square, we have the side to the power of 2, and NV, same thing, AB to the power of 2. This cannot exceed, or the allowable stress that we have in this question is 1.5 megapascal. So 1.5 megapascal, or 1.5 times 10 to the 6 Pascal, and we have the same scenario in here. And from the previous step, we already found the NA and NB, and we can easily find the area in each. So let's start with the first one. Would be basically the force of NA, which is 25 times 10 to the 3 Newton, since we have kilonewton, and we have 1.5 times 10 to the 6. So our A would be basically the square root of 25 over 1.5 times 10 to the minus 3. So let's calculate that. The square root of 25 divided by 1.5 divided by 1,000, that's gonna give us 0.1290. So 0.1290 meter for A, actually 91. So that's gonna give us 0.1291, 0.1291 meter. That's what we have for A. And if we do the same thing for B, AB squared would be NB. If we get back here, we have 135 Newton divided by 1.5 times 10 to the 6 Pascals. So our AB in here would be the square root of 135 divided by 1.5 times 10 to the minus 3. So 135 divided by 1.5 divided by 1,000. This is going to give us 0.3 meter. So if we get back to the question, we had a note that we have to report the dimensions to the close to the nearest millimeter. So for the first one, we're going to multiply this by 1,000. So it will be 130 millimeter. And the second one would be 300 millimeter. So that would be the final answer for this question. Hope everything made sense. Let me know if you guys have any questions. We are covering different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problem in your mind that you want me to cover it in the next videos. And you guys take care. I'll see you in the next video. Have a good one.